So the second part of the process is testing the hypothesis. So we know that X is the number of healthy phones. So if you think about this, there are only two scenarios or two outcomes that can happen when you pick a phone. Either that phone is healthy or that phone is a faulty one, right? So it works like a binomial. Either it's a success or it's a failure. You either hit or you miss. You do or you die. So there are only two outcomes when you are analyzing a phone. Either that phone is a healthy one or that phone is a faulty one. So we can kind of say we are doing a binomial distribution here. Why is it binomial? Because there are only two outcomes that are happening. Mr. Thomas claims that the probability is a fixed probability, which is 0.85. And one phone being faulty doesn't affect another phone being faulty. So they are kind of independent of each other as well. So you have a fixed number of phones, you're taking a small sample, you have a fixed probability, and one phone being good or bad doesn't really affect another phone being good or bad. So they are independent. So based on these three things, you can say we can do a binomial test here. So the sample that we took, how many phones did we take? We took 15 phones, and then 7 out of the 15 are healthy. Okay, so this is the result that we have got. So based on the test that we did, we got that 7 out of 15 are healthy. So we are going to run a binomial test. So X is your test statistic, where X is the number of healthy phones. And X here follows a binomial distribution. It is binomial because it's either faulty or if it's not faulty. The number of times you tested the phone, you took 15 samples. So 15 is the number of trials that you have done. So that is the number of trials. And then the probability of a success. Success here is the phone is actually healthy. Mr. Thomas claims it is 0.85. Okay, so this is your initial testing mechanism. You are doing a binomial testing, and then you are doing 15 trials under the claim that 85% of them are healthy. Okay. Now what you're going to see is we're going to check if this is the claim. If 85% of them are in fact healthy, the chance of getting 7 or less phones. Okay? Why am I taking 7 or less? Because it should be a bit suspicious if you get 7 or less as healthy. If you get more than 7 as healthy, then that's okay. He might be saying truth, right? But if you're getting 7 or less to be healthy, we want to know what is the chance that out of 15, 7 phones or less than 7 phones are being healthy. So what we do is, we're going to go to, do we remember how to do this on the calculator? Can you try this on the calculator? So we're doing P of X less than or equal to 17. So that should be okay, maybe I'll show this. Right, so you go to your menu, and then you have distribution, We are doing less than or equal to 7. So which distribution should I pick? Cumulative distribution. So if you press, so this is normal PD, normal CD, inverse normal binomial PD. I want binomial CD, so press the down arrow. That should give you binomial cumulative distribution. Press the equals button, press 1, and then we are doing variable, so that's 2. And then x has to be less than or equal to 7. Number of trials that I've done is, press the equals, number of trials is 15. And the probability that Mr. Thomas claims, that is 0.85. So the probability of this happening, and the number is 6.096 to 10 to the power of minus 4. So the answer that we get is 6.096 times 10 to the power of minus 4. That is 0.0006. Well, let's call it 61. Now, in terms of percentage, what percentage would this be? This would be 0.061 percentage. So, if this claim is true, then the chance of getting 7 healthy phones out of 15 is only 0.061 percentage. So do you think that is normal? No. Okay. So we have to establish what is normal. So then the question is, what percentage is normal? You got less than 1%, so that's not even 1%. But then the question is, what percentage will you consider as an okay percentage? We call that as, that is where you draw the line between what is normal and what is not normal. So in statistics, we call that as, that is sort of a, if I say it, like an error kind of thing, okay? So Mr. Thomas might have made an error with his 85% claim, but he can't be this off, okay? This is way too off. Then the question is, where do you draw the line between what is normal and what is a fake? So the question of what is normal brings us to the next idea. We call that as the level of significance. Level of significance is where you draw the line. And usually it can, the standard percentages that we take is, you can keep a 1% level of significance. So that means if the answer was less than 1%, I mean more than 1%, we're going to say, okay, well, that's based on you. Okay, you're saying 1% is normal. So if the answer that you got was more than 1%, then Mr. Thomas may be saying the truth. You could also choose 5% as your level of significance. That means 5% is your cutoff line. If you get an answer that is more than 5%, well, that is normal. You're basically saying, what do you want to be normal? So if you say 10% is normal, and the answer that you're getting is less than 10%, so something that is happening less than 10% is not normal. Okay? So depending on the question and depending on what you want to choose, you can choose whatever is your percentage as normal. Most of the time, we take 5% level of significance, which means, let's say we did the math here, and at the end, we got the answer as, instead of this, let's say we got the answer as 0.057. Okay? So imagine we got, this is the answer. And then in terms of percentage, that will be 5.7%. We are choosing normal to be, or we are drawing the line at 5%. So 5% is normal. The probability of this thing happening, well, you got that as actually more than that. So what Mr. Thomas claiming might be true. Okay? Because 5% is normal, that can be taken as the normal error or the tolerance thing. And if the answer that you're getting is more than 5%, that means what you're saying is there is a 5.7% chance of, the 7 out of 10 happening naturally. Okay? This is what you get as the result. And according to you, 5% is normal. And what you've got is more than 5%. So what you're saying might be true. Or what Mr. Thomas is saying might be true. But let's say instead of 5%, you got the answer as 0.039, which is in fact 3.9%. So Mr. Thomas's claim being true is only 3.9% true. But in reality, we are saying normal is 5%. So this time, the claim actually came out to be less than 5%. So his claim is not true. Okay? So this is your result. That is where you draw the line. So some questions will ask you for a 5% level of significance. Some questions might do 10%. Depends on the question. You just have to compare your result with your reference. If something is less than the reference, then that means that is too good to be true. If something has a very less percentage of happening, and if they are making the claim that all of those phones are healthy, then there is a very slim chance of their claim being true. Okay, so that is that. But if the answer is more than the 5% thing, then what they are claiming might actually be true. And that is how you actually test if something is true or not. And this is the entire idea of hypothesis testing. Is this okay? We'll do one more example.